software developer, been working in C# in one form or another for about 15 years, I think now. Started off for a tiny little local company doing apps for buses. Moved on to Capgemini, working for the people who do the software systems that process your taxis. I'm sorry. I'm sorry. Then I worked for The Works for a bit. That was quite education, the place that does the books, that one. I've just finished working for Protolabs, which is a US-based manufacturing company, 3D printing, injection molding, all that sort of thing. And believe it or not, do an awful lot of very high-tech coding. I'm currently working for European Scientific, who may be familiar maybe to some of the guys in this room. You're one of our customers. We do food and drink testing. But not me, I do the software. I have been able to fulfill a lifelong ambition to go into a lab wearing a white coat, but then they took me back upstairs to the computer desk and I got on with my job. Awesome. So, program of events, because I like films. I don't have shared agendas, I have programs of events. So we're going with who, what, where, when, why, how in a slightly disproportionate quantity. This is roughly how I'm breaking it up. So first off, who is functional programming? More important question than you might imagine. So I'm going to show you three gentlemen here. One of them is a software engineer, see if you can guess which one. So this gentleman though is Alonzo Church. He is a mathematician from the beginning of the 20th century. This down here, there we go. This down here is what he is particularly well known for in our circle. This is an equation, a formula written with its parameters here, and then an arrow, and then the actual formula. The relevance to us, as well as the arrow, which will be familiar to you, is this letter right here, which denotes a parameter, lambda, hence the term lambda expression. This is Haskell. He's Haskell Curry. There we go. Haskell Curry. He has no fewer than, I believe, 3 programming languages named after him, as well as currying and Haskell Curry. This down here is an example of currying. I will get on to that in a bit. Could this guy be the software developer? Could he be? This is John McCarthy, inventor of the programming language Lisp in the 1960s. This was the first functional programming language. And so far as I'm aware, still in use today. In fact, just today I saw Uncle Bob Martin tweeting about how it's almost impossible to get rid of Lisp because it's just so good. Never worked in it myself, can't comment, but it is certainly significant. Now, what is functional programming? Not. First off,
I'll get you a charger.
Okay. First off, it is not new. The point of showing you those previous few slides was the functional programming is nothing new. It's not the latest trendy framework. It's not Angular 20 or whatever it's on now. It's not any of these things. It dates all the way back, in fact, to the late 1800s. I spent a slightly wasted Saturday afternoon trying to trace it all the way back and spent a lot of time looking at mathematical textbooks that made mine a year believe. But it is, in fact, very old. It's not a language, it's a paradigm. This is the same as object-oriented as a paradigm, procedural is a paradigm, so is functional. If you want a metaphor, consider a guitar. A guitar can play blues, it can play rock, it can play country if you have no soul, but it is still fun. In this instance, the guitar is the programming language, the style of music is the paradigm. That's what functional is, the style of programming. Thank you. It's not imperative or object-orientated. The people that I come across that have the most difficulty working in functional tend to be those that are most heavily invested in one of those other paradigms. The guys who are heavily used to working with object-oriented and have for like 20 plus years, those guys tend to struggle, whereas the folks I've talked to coming straight out of university, they just pick it up no problem. It's not the solution to all your problems, it still has issues, but it is the solution, I suspect, at the moment to a lot of problems. And I'd argue it's not difficult. Not really. Different, but not difficult. What is it? These are the concepts. Are we getting brighter? How's that for reading? Can you guys at the back see that? Yeah. Okay. If you're having trouble seeing what anything that's written, just let me know. Okay. So, the important concepts in a functional programming paradigm. Immutability. This means that once you've set a variable, you can't change it. It makes things. This seems strange, but once you've started practicing with it, it kind of forces you to write functions in a way that make them an awful lot more solid and easy to predict in terms of behaviour. High order functions, funky name for something that's pretty simple. Functions returned as the result of a function, or functions taken as the parameters of a function. Functions passed around as if they were variable types. That's all it is. JavaScript's been doing it for years. It relies on functions, not statements. Statements are if, statements when, for, things like that. We don't, as a rule, use these things. We use everything is composed of functions. We'll get to some of this later. Referential transparency. You might also have heard of pure functions, same sort of area. That's a function where, given the same parameter inputs, it will always give the same output no matter what. No matter the life of the universe, no matter the state of the system. Unless you bung a rock through it, I suppose. But other than that, you'll always get the same result. And an entire application composed entirely or as much as possible of pure functions is very predictable and easy to work with. The ideal is supposed to be that in a functional language, once it's running, it's almost impossible to make it stop, allegedly. Recursion, you guys hopefully are all familiar with that, function calling itself, yeah? Yeah. Pattern recognition, we'll get to that. Stateless. That means, again, referring back to your referential transparency. Stateless, it cannot refer to your variables can't change their value, it can't nothing that tracks state, you can't refer to anything that's outside of your function. Monads, that's got a line through it. According to Douglas Crockford, the curse of the monad is that once you understand what they are, you lose the ability to explain them. So I shan't. Ish. And once again, I'll emphasise, it's not necessarily difficult. Where is it? So where is it? Yeah. Where's it good? Where does it work? Where is it particularly worth using? Rather, where do you see it? So you've got your functional languages. You've got Haskell, Erlang, Elm, blah blah. There's quite a few of them around. Lisp, I mentioned Lisp, the Lisp processor language. That's still around. There's these guys. I haven't used any of these personally, I've heard great things. Got JavaScript. That, believe it or not, is far more functional even than C# is. JavaScript can do some really wild and wonderful things. And C# itself, which is why I'm here. So yeah, when is it? When is it good? Data processing. This is the sort of thing it does really, really well. As I say, it relies on purity, on a lack of side effects. So data processing, data comes in, other data comes out. Dead simple. To do that, go on. Current systems, that is lots of stuff all running in parallel. This is things like multiple instances of the same application all stashed in parallel. This is async. This is Azure functions. Anything like that, functional supports it well. Lack of state means that async and things like that are supported, and it will aid you if async is what you want, if Azure functions is what you want, anything serverless that is, anything of that sort, this will work with it. High criticality systems, as I said, it's allegedly very hard to make these things fall over, so if the stuff's really important, if you have to keep it up no matter what, then again, this is what you want. Serverless, I already mentioned that. When is it not? You can do these things, it's not that you can't, but these are the areas where it gets a bit fuzzy. These are the fuzzy edges where it's not necessarily going to give you all the benefits that you get in other places. That's UI, external interactions and I/O. That is, interactions with people, interactions with the file system, anything in the outside world, and particularly people. There's nothing less pure than people. Why is it? So why do you want this? What's the advantage? What's this going to do for me? It's concise. It's just the first thing. It's not a small thing, I'd argue. A concise program is easy to read, it's quick to read, it's quick to understand, and therefore easier for somebody to just pick up out of the box. I'll give some examples in a bit. Readable. Same thing, really, yeah. It's easier to read. If you write a functional program well, it reads almost like natural language. It's extremely testable. I'm referring again to things like the pure functions, to the lack of side effects. So it's very easy to pass test data in and get a predictable result out. So it's none of this worrying about replicating date times or interactions with the outside world, that sort of thing. You don't necessarily need to worry so much about mocking. It's robust and it's fun. I like it. It makes me happy. How is it? So this is the slightly new look talk, so if you come on, give it in a minute. We reading that? Is that what, can everyone see that? Okay, thank you. Okay, forgive me if I pause once or twice. This is the slightly retooled version 2.2, so hopefully it should be easy to read than the last one. So this is example 1. This is a bit of non-functional code. This is a bit of old-style, object-orientated procedural code. So what's my task? My task is, if anyone recognise these names? Oh, I'm disappointed in you all. Oh, no, I got a few nods. These are the first set of stories adopted. Because I like adopted. And why not? It's as good an example as ever. So what do I want to do? I want to break these apart. I want to do some processing. I want to do some parsing. And then I want to put together an array which has got the list of the best stories, according to me. Because I don't know, because I want to. So how would I do this non-functionally? Well, like this. Now, you guys could probably, a lot of you guys could probably pick this up pretty quick as to what that was doing just by glancing at it, because you've been working on it for a long time. But anyone who is not familiar with this sort of exact pattern, the for each loop, the add, is going to find that quite hard. You've got logic split all over the place that does similar things. It's not very readable. It's not ideal. It does work. It's fine. Trust me, these are unit tests, so I'm not going to bother running them, but these do work. So how would I do this functionally? A bit more like this. This is the same exact input. Now, this will look familiar. Come on. This will look pretty familiar probably to an awful lot of you. That's Linq. That's because Linq is functional. If you're using Linq, you've already been doing functional programming to some extent for quite a long time. Sorry? Okay, but let's have a look at this. So we can see quite easily, in a glance, line by line, what this thing is doing. Each task is split out uniquely into a line of processing, and it's pretty easy to see how it works. It's pretty easy to see what it does in the order that it does it. And on top of that, it's quite easy to just shove an extra line in there if you want to change things. In this case, in fact, I have, if you see right there, I stuck in an order by because for some arbitrary reason I decided to watch them in alphabetical order. Because why not? Now I can. Whereas if I'd wanted to do that on the old style, that would have been a bit harder to accomplish, and it would have been less clear what I was trying to do, especially as that's a strange thing to do in any case. But I've got to select. So I'm doing a split, which splits on a new line. I've got then another split in a select, so I'm starting one single string, going to an array of strings, then I'm splitting that array of strings into each an array containing items out of the, effectively that's the CSV up there. Then I'm selecting out just the first item, and then I'm doing an order by. That's pretty easy to follow. Now, this is basic stuff so far. Bear with me, it will get more complicated. I'm just starting us easy. Okay. Oh, and yeah, and if you wanted to as well, you could do something like this, where I could split each of those guys out, each of those operations into a named function, something like that. So I'd say that's even more readable again. I mean, that is literally, you could just read down. It says split on common, what is that? That's a func, a string, returning string array. That's probably slightly easier again. We'll get onto some slightly more interesting examples in a minute. Now this is one I am very familiar with from my time at Capgemini. So what this, Nino, everyone happy with that term? Not that it really matters. National insurance number. I can tell you never worked for HMRC. So, a national insurance number. This is, a national insurance number is like a couple of letters, some numbers and a letter. And they have to be in a particular format. There are certain limited numbers of characters that can be used in certain places. It's quite complicated, and this is my hypothetical. I want to validate my Nino. So this is non-functional code. So how would I do this here? Well, this is rather a long function. It's about 50 odd lines long. It's very repetitive. We've got lots of new regexes, got lots of is matches, we've got lots of things that kind of doing similar jobs. We've got got a length thing here, but all sorts of stuff going on, and we've got returns all over the place, one there, one there, one there. We've got loads of returns, loads of them in the final. Yeah, stuff split all over the place. You would actually have to read that, probably read that through a couple of times to understand what it was doing. I mean, this is a simple example. But imagine that this was more complicated business logic. You can see how this could easily balloon out of proportion as we add complexity in. This is relatively simple, and yet it still would take me a while to parse what it's doing. How else can I do it? Like this. There we go, that's the line to go. Easy peasy. So what have I got there? This is an array of funcs. Are we all happy with func? Yeah, that's a function stored as a variable. I've given them names up here. I could have merged all this into one if I'd wanted, but I just find it slightly more readable. There's another way of doing it, I'll show you this. But here we go. Each one of these funcs takes a string, returns a bool. Each one performs a different operation on the incoming Nino, and then returns true or false. We have over here. These are actually equivalents to all the code you saw before, mostly regexes and one length check, but other than that it's pretty clear what it's doing. Here, this is an array of funcs inside and then from the array I call the .all. So what does it mean when I call all? Well, all goes through the items one at a time, evaluates them, and since they all have to return true in order for the whole thing to return true, the first instance it gets of one that returns false, it just rejects the whole thing out. So, if, for example, my item number 3 there returns false, well, it will exit at that point. These 3 guys, the last 3, will never execute. So, even though I haven't bothered to write out that early exit from the function, it's doing it for me. It's already there. There's an awful lot of logic encapsulated in that simple few lines of code. If anyone wants to tell me that's not more readable than the other one, I shall have arguments. Oh, no, sorry, just a second. Yes. And if I... there we go. So then, if I scroll down, I've got a slightly more enhanced version. Hopefully this will show up on screen. This is an extension method. Are you guys all happy with extension methods? Anyone? Yeah, good. So I'm extending this from T, well, I call it T input, it's T. It's extending T, which means this applies to everything in the entire C# language. And I'm adding in a function called validate, which takes params of func, which is T input and bool. So what does that mean? That means that you don't have to bother creating a new array out there, you just pass them in one at a time and it'll just implicitly stick them all in an array for you, and then you can do the exact same thing. We can do that all and call each one in turn. So, still the same thing, but looks slightly nicer. So there you go. I've extended out the C# language so that now any variable type has an extra function on it called validate, and all you have to do is pass it a set of functions, each of which is a validation rule, and then it will tell you that that's valid by returning true or false if any single one of those returns false, in which case it will come out early. So it's pretty tight. And I've tried to enhance the reusability of this by breaking everything down into composable functions. So before, each one of those functions was very specific. It had a very specific use, it had a very specific use case. There was only one way you could use it in one place, pretty much. Whereas now, I've tried to break it out so that it's all as reusable as possible. So it made them a bit more generic. I mean, rather than have a function that checks whether length is 9, now I've created an extension method for strings called hasLengthOf, and that will just tell you whether whatever you've just passed in is the appropriate length. So it's 9. So easy. I've broken out regex. The regex thing, the regex call, I've made that a function that takes any given regex string. And where is that? Oh, it's here. Here's one of the set. Oops. There we go. Oh, no, see right in there. Okay, there we go. It's called regex match, which is there. Okay. So I create an extension method which attaches to string, and then all you have to do is give it a pattern, and then it will run that through a regex and return whether it matches or not. So now every string's got something that will give it, you can pass a regex match into, and then simply return true or false, which is used actually by some of these other extension methods to check things like, is it alphanumeric by passing in a specific regex, or is it numeric like that? There's all sorts of things you can do here. You can build on things and build on things. You can have functions that call functions, and what's happening is that to an extent you're not sitting there and writing all of the functionality from beginning to end, being particular about the order of operation, being particular about what's done where is stored where. we're gradually composing functions that are used by other functions that are used by others, until eventually the final product is just this sort of emergent property coming out of this cloud of functions you created in the background. So the amount of new, and if you make these as reusable as possible, like I have, then the amount of work that I need now to create a new validate loop function is pretty small. So that's the whole Benino thing done. But if I had something else I wanted to validate, some other string, it wouldn't be much effort to just throw in a couple of them. Maybe that the set of characters would be different. Maybe there'd be different sets of numerics or not, but it wouldn't be very difficult at all. That would be, and it would be equally readable. You could have a whole load of these all next to each other. It'd be very easy to tell what each of them does. And if the definition of Nino ever changes, again, it's pretty simple to just throw an extra line in, take a line out. So this is really easy to maintain compared to the object-oriented alternative. And like I said, just give that to anyone, and even if they don't know programming, they could read that and just tell you what it does. Now, they wouldn't necessarily understand the detail, but that's something for us to deal with. But they'd understand what it did. And that's a win. Number 5. Okay, so this is another sort of example of something we can deal with. So let's imagine for a moment that we've got a really simple bank account. No one's bank account really works like that, but this is just, we're keeping things simple. So we've got a standard bank account, it's got a balance and an interest rate. We've got a super duper bank account, we've got an extra bonus interest rate because you're our friend. And we've got a dodgy bank account, which has got a brown paper bag left in a car park containing wads of cash, because you're Mr. Hamilton. So, we've got a whole load of rules here. We're saying things like, if it's a standard bank account, then we just say that the interest is multiplied by this. If it's a super duper one, then we're expecting to add on the bonus interest rate. And if it's if it's a dodgy bank account, you just simply add the lump sum from the brown bag of cash. So these are unit tests. So how's this done? Done kind of like this. Now, in a real functional language, you'd be able to do this as a function too. At the moment, you can't, not in C#. You will be able to as of C#8, Word has it. I was at NDC Oslo last year. I had a chat with his name Mads Magnussen, the head developer on C#, and he said, "What are you doing in my room?" And after I got tied up and beaten and arrested, they said that the whole point at the moment for the progress of C# is that they are going to increasingly make it a hybrid functional object-oriented language. Each version of C# from now on is going to have more functional features. In fact, C# and F#, its functional counterpart, are actually aiding each other's development. The new features that are being requested by F#, the more functional word, are also then being added one way or another into C#. So inevitably C# will be more functional. Another thing that's coming in C#8 is going to be things like, not exactly immutable variables, but it can be set so that you'll get a compiler warning if something can have its state changed, which is great, it's a step in the right direction. They're considering the idea of actual immutability, but I think they're concerned about backwards compatibility on that. But anyway, what we're going to do here, so some of you might be using this sort of thing already, but you would be surprised. We're taking in a standard bank account. Standard bank account balance is less than 10,000. So you can not only case on the type, you can also case on the properties of the type. So this is all C# right now. This is available right now. So as of C#8, I don't have any examples to show because it's not quite out yet, and I haven't installed the preview version of Visual Studio 2019. But if you do, you can play with it. There is an entirely enhanced version of this, and this section will have to be updated, unfortunately for me, in a couple of months' time. But it's using this sort of like JSON-style syntax to do some very complex selects against the properties of the bank account coming in that we match on. So you can do an awful lot of very sophisticated, very complicated logic based on the properties of the incoming type in just a few lines that are quite easy to read. Now, this is a switch statement at the moment, which I said we were aiming for functions over statements. That's true. This is a statement. We can't avoid this one at the moment, but as of C#8, this will be a function. So you can do away even with this statement. And this is a last example in this series. So this is a rule base. So I'm coming up with a really simplified version of applying tax. Did I say I worked for HMRC? I didn't know. So this is just a really ridiculously simple version of what tax rules are actually like. This is the sort of tax rules that make Rupert Murdoch's 50th bit. But so we've got. Okay, so we're applying tax if you are on 11,000 should be tax free, and we've got. There we go. I'm saying that if you have a salary of 40,000, then we should have a bit of tax paid off. If you've got a salary of 40,000, we should have quite a lot of tax paid off. And then we've got, there we go, our high income guys that pay, was it 4.5%, whatever it is. And this is how I would do it. Technically in one line, although I'll grant you that's quite a long line with some new lines I've scattered throughout it. So what on earth is all that one? Now that's doing a lot. That's doing a lot in a short space of code. So this is another array of funcs. There are 2 funcs in each one of these. This is an array of tuples, in fact. This is a tuple array. Each side of the tuple containing a func. The first one takes a decimal, returns a boolean. So what is that? That one is deciding whether this is the appropriate rule to apply or not. So I'm saying, is it less than or equal to 11,850, that is you don't pay tax? Are you earning therefore less than 46,350, and so on and so on. These are all the different rules to determine which tax bracket you belong in. I'm using a first applies to the first function from this side. So what does that mean? It means it will go through them one at a time, and then the first item in there that returns true, i.e. the first one from this side that returns true, that is the entire line that will return out. That means the first one has been executed and returned true, but we have the whole line. And the other side is actually the rule to apply, the actual multiplier. So in one line there, we have selected a rule based on the properties of the incoming object, and then returned a function that will transform the input in the way that we want it to be transformed. That took me an awful lot of time to explain, but I did all of that in a very tiny little few lines of code. And again, really easy to modify. What if the tax rules change? Throw a line out, drop a line off, move one of these numbers a smidgen. Easy. It would reduce the amount of code staring required to find the place to make the change. It would reduce the amount of code change, and because you're changing so little, it's improving the chances that the new code ain't going to break. It can tell in a glance what it's doing. So there's none of this business of code review. You have to go up and down trying to work out what you're up to. It's pretty clear. So, a couple extra things to show on before we return to the slides. These are functors. Functors are kind of like little bits of functional glue, I suppose, is a way of thinking of it. Take some functions, glue them together in a particular way with some logic, something along those lines. So, this one's called alt. I've heard it called other things. There's no real standard for this stuff. I've heard all of these things called lots of stuff. I've heard this one called alt the most, so that's what I'm going with. But this is, you've kind of got a couple of ways to get in the same data. You've got way 1, way 2. Maybe there's the first database source and then the second database. Maybe there's the cache and then there's the live, go get the actual data fresh from the database. I don't know, I don't really care. Whatever. But the point is, you've got 2 ways of doing it, and you just want to go through them until you find one that hits, until you find the one that works. So in my simple example, I've got a couple of funcs. I've got one that works and one that returns null. So I know this one don't work, this one does. And that one just says this works and then sticks whatever you gave it a string, on the, and put that on the end. It's not very complicated. My actual code is this one line here. So everything I just told you is in that one line. Input the alt, the one, and I'm giving it the one that doesn't work, we know doesn't work, and then the one that does. As it happens, it's true, this is a unit test, trust me. So how does the alt actually work? So this is another extension method. I'm extending on t, effectively again, t input, and I'm returning t, another t, output. So something coming in, something else going out. I'm taking this as my input, whatever that is. I want 2 funcs, both of which take whatever the input type is, and return out whatever the output point is. So if I'm turning a string into an integer, then I've got two functions that turn string to integer. If I'm doing string to string, then two functions go string to string. Whatever, it doesn't really matter. It could be a string to an array. It could be whatever you want. It really doesn't. With objects can be used here too. And I'm saying run the first function with this as the input, and then I'm calling this extra thing, which is if default do, which is down here. Now, what does that do? That looks a little bit scary here, but it's not really. This is basically just doing is null. This is the sort of generic method of saying is null. It's using the equality comparer, and I'm just giving it whatever the output is, whatever that is. So this means that it just checks whatever the value in whatever type it is against whatever its default value would be. If it's an integer, that'd be 0. If it's a boolean, that's false. If it's an object, a string, or almost anything else, it's null. So that's all that is. It's saying, did this actually give me a value? So we take, and then we give that this. So that means that this here, as it were, sorry, this, if it's, actually it's the return type of this, whatever that came out of this, whatever came out of this execution of the first function, check whether it was effectively null or whatever. If it was null or whatever, then we run the else function. That's this one, function 2. Otherwise, just return the value that just came out because it's good. So this means run function 1, and if it returns null or equivalent, run function 2, then return that. Otherwise, just return whatever came out of function 1, it's fine. Slightly complicated couple of lines of code, but to be honest, you write these once and then you don't worry about them anymore. Shove them in a box, don't need to care, it works, it's magic, it's good. You can unit test the heck out of them and know that every single time you run them, they work. The whole point is that from then on, throughout the rest of your application, just do whatever the heck the type is as your input, .alt, give it 2 operations, it'll try one, if that don't work, it'll try the other one. Easy peasy. Now, there's all sorts of ways you could extend that. You could add 3, you could use the params, you could do all manner of crazy things. I'm keeping things a little simple, but you guys can use your imagination. There's a lot that you could do with this. I've run into slightly silly examples where I've ended up with intermediate changes in the middle of, you can get very complicated. But, as I said, use your imaginations. So, function number 2. Fork. This one's fun, I like this one. I haven't found very many uses for it, but I've felt very proud of myself every time I found a use. So, in this silly example, I want to take this input string here, A, B, 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 C, 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 D, 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 D. There's a whole load of repeated characters. I want to take a count of A's, a count of B's, a count of C's, and then add them all together. This is a silly example, but the point is that I want to look at what the structure is. So what is a fork? So a fork takes a set of functions. In my case I've given it 3. I think I've used the params here. You can set that how you like. It takes each one, takes the input and turns it into something else. And then you've got a single function here which glues them all together. So think of this as you've got the input at the beginning, we split off into 3 different paths and then meet back at the end. And this function here, this x, is an array which takes the results from the other 3. So these, as it happens, are all x.count, so this is turning a string into an integer. This is an array of integers which contains 3 items, which is a count of A, count of B, count of C, and then just does an x.sum, so we get our answer. Now that's probably slightly overbaking a solution to a simple problem, but you can see how in slightly more complicated circumstances you could make some use of that. And all of these would probably benefit from being turned into async as well. So it might not necessarily just be data crunching. These things could be database operations. These things could be calls to APIs. It could be all manner of things. So it's not all that different to the JavaScript way of having set promises and a then at the end of it. As I say, let your imagination run wild. So I think at this point we return back to our slides. Cool. Carrying. So I did set. Oh, hello.
Just a quick question about what you just been talking about.
Sure. Sure.
Is there like I feel like there may be a few of them, and is there a sort of de facto NuGet library all best ones probably.
De facto, not that I am aware of. I will mention one at the end. To be honest, I largely ended up baking my own whenever I've done this. But it's kind of see like those functors, they're very small. I've yet to see a functor that was more than like a line or so. So I personally don't have a problem with just baking them in the way I want them. And in that way I can make them fairly specific to the business logic of whatever application I'm working on. No, I haven't seen one that's like gone and done everything. If you'd like to do it, let me know, I'll probably use it.
I'll get on that now.
So, okay. That's a little bit dark, isn't it? Okay. Can we still read that? Currying. Okay. So let's have a look at this. I said I'd talk about currying, so I am. So, first off, this is a fairly simple example of an actual function, the way they really work. I've got int a and b, and int a plus b, we get back, so we give it 10, we give it 20, we get back 30, dead simple. Let's imagine that this one here was a hypothetical curry function. So I give it 10. What do I get back? Anyone? It is, the function, yeah. So you give it 10, you get back a function that will supply the second parameter. If this was an add that took 3 parameters, and you gave it 1, you'd get back a function that had 2 parameters, that being the second and third. It's kind of a way of gradually applying the parameters one at a time to a function. It has its uses. Effectively, this add 10 has become an add 10 function now. So everything, you could store that locally somewhere, and then you could use it multiple times, and every single time you use it, it'll add 10 to it. That's a simple example, but there's all sorts of ways you could use this. A really nice thing you can do, for example, is perhaps you could have a function where the first item is something that constructs the database, and then the rest of it are operations applied to the database. You could give it the first parameter so the database gets created, and then just call it lots of times. It's kind of like instantiating a class, an object from a class. Yeah, there's the answer. Partial application, actually, yeah. Strictly speaking, currying is only if you apply them one at a time. Partial application, you can give 2. We've got an example of this. The question being, can we actually do this in C#? No, not really. Not really. Kind of, a bit. I'll show you what you can do. And I have found uses for it. I do use it quite a bit. But you can't do true currying. You can't do the thing where you just apply as many arbitrary parameters as you like. Currying in C# looks, yeah, that's what it looks like. That's the nearest we can get really at the moment. Watch this space, you never know what will come out in C# 9. But look at these are arrow functions with 2 arrows. That's the nearest we can get to currying. So this is a function that returns a function in effect. So the first time you call this add, it's applying this x, which returns, you can block this, a function which is the x, the y, the new parameter added to the x which is applied here. So it's a lambda expression that returns another lambda expression. This is the nearest we can get. You can only apply them one at a time, or in the grouping that you say. I could have had 2 supplied here and then 1 here, but you can't vary that easily. So you can do an add, subtract, multiply, divide in these instances. Each of these are curried, so you can apply them one at a time. There you go, that's how you might use it, right there. Call it the first time, give it 10, this is now an add 10, and then give them 10 there, give it 20. There are uses for this, which I'll get onto in a bit. You can actually do partial application, in fact, to a degree, although it's kind of fiddly. So it's all done via, blah, blah, blah. There we go. Yeah, look at this, okay. It's kind of like you return. Oh yeah, doesn't this look friendly? So you returning out a function. So you're taking in T1, T2, T3, T4. These are your 4 parameters, and returning a result. You're returning a function which takes the 3, the 4, and the result. And I'm taking the 1 and the 2, and then also a function which applies the remaining parameters. Yeah, it's very friendly, isn't it? You'd take it home and let it marry your daughter, wouldn't you? Right. So how can I use this? Well, here's a sort of arbitrary example of something I can do with it. So here's back to my Doctor Who stories. So here I've given them a serial code, I've given them their name and an arbitrary rating of how nice I thought they were out of 5. So I am creating a function here which takes a string, a char, an int, a string, and then returns an IEnumerable string, so it's a parser. This is it's splitting this up into its pieces and then returning an arbitrary set of them. And that's all of this. This is the whole thing. This is the whole function we're doing, is split, split, and then trimming the start, the end, and returning out the bit I want. So I can create the whole thing like this. I can give it all of its parameters, so that is split on new line, then split on comma, then take the first item, then return everything. Well, no, sorry, that's the fine, that's the input. And then that should give me all the titles. So why is that? So we started with a CSV, we split on new line, we split on the comma, that's line between lines, and take the first item, which is, sorry, position 1, array position 1, that's 0, that's 1, that's 2. So basically, in one go, we go through here and bring back all the titles. Easy peasy, but then you can do something like, there we go. So get code is, so parse here, there, this is a partial application, parse. So using parse, I used the extension method I created below called apply, and I gave it just 2 parameters. So this tells it where to split and how to parse. The rest of it I haven't supplied yet. I haven't given it input, I haven't given it which item I should select, so I am getting back something that tells me which item to select and all that. So I am here then saying, take that parse function I've just created by partially applying, and now give me the item at the 0th position in the array, that being the code, that would be here, and then I can use it again here with giving it a 1. So that parse, that giant function that did all of the stuff in one go, has now been split into a partially applied function where I can vary the rest of the parameters I give to have the same piece applied again and again, but only vary a little bit. It's the same function running again and again. So every time I reuse it, it still works just the same. Is that pizza coming in? Okay.
When it's a good time to break, yeah.
Okay, I got 2 more examples here, but we can break it, that's the time. Yeah, so I'll just quickly rush through these last 2 bits, and then we can all calm down. Aggregating. Now this is something that's been in C# for ages, but to be honest, I'm slightly astonished at how many people don't know about that you can do this sort of thing. But this is assuming I want to blast through them all and select out the title and then aggregate it into something with commas in between. You know, yeah, that's how you do it old style. That's, again, kind of hard to read. Or you can do it... where is it? Okay, that's my story data. That's breaking everything up into a story class to make it a little easier to work with, and then, where is it? I've lost it. Tell you what, let's just break. Yeah. We'll come back to this in a second. I'm drawing somewhere it was. Okay, shall I get started? Okay, I kind of remember, sorry, this is one of the most revised sections of the talk, so apologies that it took me a moment to remember what I was doing. So, the normal process for writing a functional application, which typically, for me at least, with the smartest stuff I've ever done, it's been start with one thing, start with a data item, start with, I don't know, it could be a string, it could be an object, but one thing. Split this into many things, and then apply a series of list operations to them. Stuff like selects, stuff like wheres, stuff like whatever. Linq operations, in fact. Do them in sequence, do as many of them as you want, and then at the end of it, you want to collapse it down into a single value. So that is aggregating. Taking many things and turning them into one, and that's your answer. That's been the typical workflow I've gone through. So there are a lot of ways in C# of aggregating and turning many things to one thing. Some of them you'll be pretty familiar with, others are slightly more esoteric. So, as I said, starting with turning this into just a this is an array of strings. Again, it's my Doctor Who title. But collapsing them into a single value, that's the sort of way you've done it old style. We've got a string builder, we're doing a for loop, one of the things we've got to do here is we want to put a comma between each one. I can't use a for each, because if I do a for each and append a comma each time, we'll end up with a string and comma. So we're going to do all of this sort of thing, and all it's doing is adding noise to what is actually quite a simple operation, which is take all these things, stick a comma in between them. It's not complicated. Whereas you could just do string.join. Now that's a simple example. String.join is dead easy. You just tell it what you want to join the strings with, and then it sticks one in between each string. Because it only goes in between, there's nothing on the end, nothing on the append to begin, dead simple. That's a simple example, and probably one you guys have been using for years, and if you haven't, why not? So a slightly more complicated one, if I wanted to break out into an object. So this is an object describing each of those stories. I've got the serial code of the episode, I've got its title, but its rating, the number of episodes, and the number of missing episodes. Sad fact, there's a lot of missing episodes for Doctor Who. 98. Okay. So then I've got my data, how many there, how many disks are there, how many disks. So I want to aggregate this into something like a percentage of how many episodes are missing. Too many. We could do something like .sum. Very simple. We just loop through, take number of episodes. We could do that on number of episodes missing, I think. Oh, okay, yeah. Do a sum of number of episodes minus number of missing. We've got the number of existing episodes. We've got .average. This again is all linked, so we select all the ratings and do an average. And then this is the slightly more, so most of that's just basic standard out of the box link, and then this one is a slightly more complicated example where we want the percentage. So I am going to turn the entire array of objects into a tuple for each story, one containing the total that are missing, one containing the total overall. Well, actually, I see tuple at the end, but that's in. So we start with the seed value. So this is our starting value. It's naught and naught. And then after that, you define a function which tells it which function to apply to each item of the array to change the running total as we go through. So I've used AppUKC around a lot, but that just means that cur represents the current item out of the array. If you're doing a select, this would be x or whatever you would call it. And this is the current running total. And then I am saying that this function should return the new running total, which will be used in the next iteration of the loop. So I'm saying the new running total should be the old one, .item1 plus the current item's number of missing episodes, the current running total item2 plus the current number of episodes. So item by item going through that loop. Every time we iterate through one of the items in the array, the total is being updated, and then at the end of it, we're presented with a single set of values, the total number of missing, the total overall. I mean, we could have done this example with a sum, in all honesty. We probably could have. I've also done something similar using the fork that we used earlier. There's all sorts of ways of doing this. I'm just presenting the technique. How you apply it's down to you. But there are all sorts of ways that this could be used. You could also have an array of functions, if you like, then aggregate that, where the running total is being transformed by each function out of the array. There's an awful lot of very creative things you can do with this. And this is all out of the box C#. I'm actually astonished at how many people don't even know that one exists. Certainly no one I've ever worked with ever. Right. And then just do some round again if I got that. So that's all that is. This, then, is to put it all together. This is one of the strangest bits of code I've ever written. Or you'll see it in a minute. So what I want to do is I want to start with a string. Now the string is add comma 2 pipe multiply comma 2. I want to transform that into a mobile ringtone. I want to transform that into a multi-step function. So I want it so that I've got an add2 function, a multiply2 function. Whatever input we put into it, it will apply to each of those functions in turn. The answer from each will be applied to the next. So in my examples here, if I give it 5, I get 14. Because 5 add 2 is 7, 7 multiplied by 2 is 14. If I give it 6, I get 16. 6 plus 2 is 8, 8 multiplied by 2 is 16. So each is a separate step. The answer from each is given to the next. And I'm going to do it in 3 lines of code. Slightly big lines. So, the first is a dictionary. Did you know that you can put functions in a dictionary? So we can. I am saying that the key is a string, either add, subtract, multiply, divide. That's my key. And then what I get out of it is one of these good old curried functions from before. So my curried add, my curried subtract, whatever. So, whatever string that I put into this, I get back the curried version of that string. Nice and easy. And there it is. That's actually the majority of my work there. So that's a whole functional flow in one go, doing pretty much everything I just said, with an exception that I'll get to in a second. So, this is make function. This is kind of like, this is a curried function itself. This is kind of like a constructor. This is my constructor parameter. This is a string. So that is that string stored at the beginning. That's like add, comma, to, blah, blah, blah. So then I'm saying that gives me back a function which takes input. Input is, in this case, it's decimal. I've decided I like decimal. Decimal's good. So this is my input decimal. So every single time that the function I'm about to create runs, this is its input. So then I'm doing whatever the original string was, got split on a pipe. I'm doing select. So for each, so at this point, after my string split, on my string split, I've now got an array of strings. I've got the first one that says add, comma, 2, the second one says multiply, comma, 2. Now, I'm selecting, I'm applying an operation to each of those, and then splitting each of those in a comma. So I've now got an array of arrays. So I've got an array which has 2 elements. The first element is itself an array, add, and 2. The second is another array, and that has 2 elements as well, and that is multiply and 2. So now, we do another select. So we're applying again, and this time we're saying, take the first element, that's the add. So if you do a select, so we're already iterating through the first array, the top level array. Okay. So we're saying now within that, take the first element out of the current array, which is the add or multiply. Go to my dictionary and get me back whichever function that corresponds to. So I've got an add, so I get one of these. And the second item is a multiply, so I'll get back one of these. So I've now effectively got an array of curried functions. Great stuff. So then, what do I feed into it? I feed in the first parameter. So that is do a decimal.parse of the second item. So I've gone from, so taking it an item at a time, I've gone from one big string to a string with 2 elements to an array of arrays, and now I've transformed each of those elements, the top level array, into a single parameter function, which applies one or other of those operations. I've gone back to so I've now got the first element, which is now 2, and the second element, which is multiply 2. This is great. Now the problem is, how do I get them to feed into the next? How do I get the one to give its answer to the next? Can't do a select, it won't work that way. It's not how select works. Select effectively works in isolation, so that's what this thing does. Tail recursion, that's what we're going to do. This is deceptively simple. And I believe I've got some slides which will hopefully explain slightly better what I'm trying to accomplish. Okay, so that's what I've got at the moment. I've got, it's dark as we can run. Okay, I've got an array now. So I've actually got 2 items in it. I've already put the 2's in. So the curried function has now just become an add 2 and a multiply 2. That's what I've got right now, this box. So then this is my extension method, my house. So what I actually do is to use something called an IEnumerator. Everyone heard of IEnumerators? I am impressed, that's great, okay. So an IEnumerator, for anyone that doesn't know, it's a way of kind of manually iterating through an IEnumerable. Rather than letting the for each do it for you, you'll save dot get me the current thing, and dot move to the next when I say to move to it. It starts in kind of position -1 until you move. So right now, I am breaking out the IEnumerator, so I'm going to manually iterate through this thing. and starts in position -1, and in my example I'm going to give it 6. So this is kind of my hypothetical finished, bound together final function. So if I give it a 6, and I break up my enumerator, which is going to loop through this head. But at the moment we're in position -1, so that's all we got. So what it says is, are we at the end of the array? There's a way you can tell that, but no we're not. So we call ourselves again, we call the same function again, the apply calcs, but this time with position moved on 1. And we return the new input to be the current item out of the array with the current operation applied to it. And we end up with something kind of like this. We do this each time. So we start off with no, we start off before the beginning, and we say, oh, at the end, no. In which case, move on 1. Apply the operation. And then call myself again with the enumerator in its new position, and with the first item out of the array applied as the new parameter. Then we do that again, and you get the same thing again. It says, am I at the end? No, I'm not. So, we move on. We apply the operation, and we call ourselves, passing in the new slightly transformed value again, based on the second item out of our array of funcs. And then we move on, and then we call ourselves again. And then this time it says, am I at the end of the array? Yes, you're at the end of the array. So we just return. We don't bother to iterate again, we just return. And so what you've got is finally a value which is 16. Simple, see? There'll be questions later. It looks kind of like this, if you can see. It's kind of like, think of it as being kind of like, a bit like promises. You either return a value now, or you say, I'm not going to return a value now, I promise to when I've gone round again. Until finally you can return, in which case the final value just cascades all the way out. It's kind of like, it is a little hard to explain, but once you've done it once or twice, this is not very difficult. It's just conceptually a little strange, but it's quite difficult to do. In fact, when you, we're not going to go on to that yet. When I show you again, for all that talking, it's only about 2 lines long. So that's the only reason it's 2 lines long, in fact, at all, is that I want to start with my IEnumerable of funcs, and I want to break out the get enumerator, which I can't do within the single function. So that, all this exists to do is to be a front end which converts my IEnumerable into an enumerator, and then this actually is the real thing. This is the actual line that's important. So it's saying enumerator, move next. We start in position effectively -1. So calling that to a new IEnumerator will move it to position 0. It returns true if there's a value, and false if you come to the end. So then I say question mark, that meaning, did it return true? So that means, is there still stuff to do? In which case, call myself again, passing in that same enumerator again, but this time it will be moved on, and then get enumerator.current, that means the current item out of the array, the current func, pass in the current total, which starts at 6, because that's my initial input, and then apply the first operation to it. And then go around again, until eventually move next returns false, in which case just whatever was passed into me, I just return it, without question. So you get your kind of arrow-shaped function. So that's how I do it anyway. And that works. That is exactly what I said it was. That turns 5 into 14 and 6 into 16. Now, because all of this is IEnumerables, the order of operation is actually crazy. It does things like, it'll actually kind of slice through each of these layers of operation, one after the other, in each iteration. So the order of operation is actually not all that different to if you've written it out procedurally. Except it's just not holding anything or modifying any state. One small advantage of doing stuff like this is that because we're not holding any variables anywhere in the function, we've just got our parameters. The moment the function completes, those parameters drop out of scope and are garbage collected, or subject to garbage collection. So if I'd written this all out longhand, and I've got myself a giant function, all the variables I define at the top are still in scope for the entire operation, and will not be garbage collected until the whole thing's done. Whereas doing it this way, everything is only accessed the moment it's needed and garbage collected the moment it's no longer needed. So there's kind of a lot of strange things going onto the stack, but in effect the data is only held for precisely the time you need it. Okay, moving on. Immutable types. So we talked about mutability. Mutability is important. Mutability is kind of like that's your way of ensuring that you're doing this right. That's ensuring that you are not going to try and change any values. If you work in F#, that's the way that works. All the functional languages, once you've set a value on something, you can't change it. It's a way of ensuring integrity. Can you do it in C#? Well, let's see. Apologies, it's not very legible in the light, but this is an example of a class which is totally mutable. So, what have we got? We've got getters, but no setters. The only way to instantiate those objects is to pass them in a constructor, so that's immutable. That's totally mutable. There is no way to change that once you instantiate it. Not a problem. Great. How about this then? Is this immutable? I've got an int, a string, and an iris. I'm instantiating them through the constructor, which is great. They have no setters, which is great. Is this immutable? No. No, it's not. No, it's not. I can add to it. I can add to the list. I can subtract from the list. I can apply all sorts of strange operations. I can replace a value in the list. I can't replace the list in its entirety with a different list, but I can still, other than that, it's all good. I can wipe it and then add to it one at a time, that's all fine, so that is not immutable. How about this? That's an immutable array. Now we're immutable. I can even, that setter shouldn't be there. Ignore that. Ignore the man behind the curtain. Right, so that's immutable. Wonderful, super duper. But then, I've decided in a subclass. Now I'm not immutable. What about a third-party library? What if I'd added a class in from a third-party library as a parameter? Not immutable, and nothing you can do about it. Nothing at all. You can't control a third-party library. There's basically no real way of doing it. No way of being sure that you can make things immutable in C#. You could go to some extraordinary lengths with only doing constructor-based creations. And to be honest, the code you'd end up writing would look pretty unfriendly. I'm a big fan of just making the code look lovely and simple. So, my personal opinion on this, you can go most of the way to immutability, but not all the way, and to be honest, I'm not sure what the point is. I would prefer just to pretend that everything's immutable, and proceed like that. If I can, I would like to write all of my applications using entirely arrow functions, which would effectively ensure immutability, because you can't store a local variable inside that. Using select would be entirely immutable because you're just creating a new array using the old one as source material. So that's how I would proceed. It's not really very purely functional, but C# is not fundamentally a functional language, it's a hybrid. It supports all paradigms. Ooh, chaining. Now we're going to have some fun. Okay, what's that? So, we've looked at some methods of chaining stuff together, but that's got its limitations. Here, I used to work for an American company, and here's something I'm quite familiar with, is converting the temperature between centigrade and Fahrenheit. Because sometimes my American colleagues would say, oh my god, it's 100 degrees outside, and I'd go, what? How are you not dead? Oh, wait. Okay, it's fine, it's nice. Okay. So, what is the operation for transforming from Fahrenheit to Celsius? We put 32, multiply by 5, divide by 9, because of course you do. And then, just to make it look nice, I'm going to round to 2 decimal places, and then I'm going to append a nice degree centigrade on the end. So that's how I would do it old style. This is not functional yet. Again, there is no way to do this without taking the return value from each item and then performing a new operation. I could use my super duper function that you saw before, but there are other ways of doing it. Slightly more rigorous ways where we can do some error handling and stuff like that. So we are going to have a look at a different so let's have a look at a slightly different way of doing it. So once again, I've got all of my current add, subtract, and blah blah. I've got myself a single function which does my conversion. It goes from 100 into the correct centigrade, which is, oh, it's 37.78. It's nice and warm now. And this is the simplest way of doing it ever. This is the simplest, most reusable way of doing that operation. Dot map. This is not a C# function, this is another extension method. Looks like this. It's very simple. So it's just a from type, a to type, and it extends key this, the from type, and it asks for a function which turns the from into the to. So what I'm saying is, given this, which is whatever it is, the string, the object, or whatever, give me a function that turns it into something else, and then I'll return it a new thing. I will apply the function for you. So the advantage is that you can chain them like this. Since map exists on everything, you can just simply call map off the new return. So I do map, and I'm passing in a multiply 9, which is one of my curry functions at the top there. That returns me a new decimal, and then I just map it to a divide 5, map it to an 8. These would otherwise all be arrow functions. I could write these out as full as arrow functions, but since they're functions, you don't necessarily have to bother with the arrow in this case. But here down here, with my map.round, I do have to use a full arrow because I need to give 2 parameters, and once again, they convert to string. I could split those out into my own extension methods, or I could turn them into all sorts, but for the sake of illustration, I'm keeping it simple. So that's a very simple way of chaining as many things as you want. And again, it's nice and readable. If you wanted to know what this thing did, you just look at that and read it. I could pass that to my manager, and my manager would know what that is. Easy peasy. But we can do better. We can do better. So this is a slightly improved version. This is a structure called an identity. I don't know why they call it that, they just do. So I'm going to do some more interesting things with this but I'm adding the complexity one thing at a time so as we don't get overwhelming. So an identity, what's the point of an identity? An identity is just a box to put something in. And the thing in the box is whatever. It could be a string, it could be an int, it could be a decimal, it doesn't matter. It's a box containing the value. And then I can hang some functions off that box to change it however I want. I made it an identity of t. So t, for most of the operations you saw above, is a decimal. I'm doing a couple of static implicit operators. Implicit operators? Anyone confused by those? Yeah, just a bit of syntactic sugar. You can just make an identity equal to a decimal without having to bother with all that casting. Just makes my life slightly simple. I like nice simple code. And then I've got a couple extension methods. One that hangs off t, this, which is everything, and it says whatever this is, turn it into an identity. And the other is bind. And bind is really just the same thing as map. Bind is just another terminology you'll see an awful lot when you start reading into functional stuff. It just calls it bind. That's the more accepted term from what I gather. It's the same basic principle. Take the from type, the to type, give me a function that turns one into the other, and we can chain. What does that look like? Pretty much the same, exactly. So we start with our inputs, we turn it into an identity, and we do a series of binds, each one taking a function and transforming it one to the next. Still fairly simple, but we can still do better. So let's have a look at this item. So we've got persons, there's me, I need to put that what are we doing? Right, yes. So what we're doing, because I am cool and wicked, I am converting my name into Linq speak, because why not? Because I am cool, like I said, I want to be down with the kids. Kids are still doing that, right? Right? Well, so I want to swap all of the I's for 1s, I want to swap all of the O's for 0s, the A's for 4s, and I'm going to wear my cap backwards and say cowabunga. That's cool, isn't it? That's still cool? No? Okay. So, that's cool. We can do the binds, we're doing replaces, still pretty simple stuff. So we're starting with an object, we're taking the first name, the last name, we're appending my age, we're doing some replaces. And what if... Right, okay. So what if the person ID is, what if it doesn't return anything? What if we don't get anything out? What if we're doing an operation looking up in the database and there is no record? What if actually this would return null? Well, that previous function you saw, where I'm getting all properties off my object, that I'd throw a null exception error, good old null exception. So I don't want that, and in my chain, how am I going to do an awful lot of if null fly? There's a lot of ways of doing that, but this is probably one of the simpler ones. So I'm using a slightly more advanced version of that identity that you already saw, but this time I'm calling it a maybe. Maybe because maybe it's got a value, maybe it don't have a value. But I'm still using my binds. Other than that, it looks exactly the same, excepting that this one uses get person 2, which I believe returns a null. Yeah, so there we go. Get person 2 is my hypothetical database operation. Maybe it's an EF lookup, maybe it's, who knows, but it returns null. So this, if I ran this with an identity or a map, would throw a dirty great error. But it doesn't. This doesn't throw an error. This returns a null, but that's fine. We can accept that. Even though the null exception error should have occurred here, and we'd have a whole load of operations after it. So how do we do that? Here it is, my maybe. Okay, so here's my maybe. This is nearly the same as what you've already seen, except there are it has two states. So we start off with an abstract class, that's the maybe. It's an abstract, a key. It's got a value in it, just the same as the identity. It's got some implicit operators, because I like just simple code. I don't like to clutter. So then I create two implementations of my abstract class. Here I've called them just and nothing. This seems to be one of the more common descriptions for these states. I've heard it called something and nothing. I've heard it called some and nothing. I don't even know. Call it as you want, I really don't mind. But the principle is, the maybe has two states. Something, or just, or whatever, where I've got a value, it works. I got a thing, here's my answer. And nothing, where it didn't work, it failed. And I don't know which one I'm going to get at the end. And what I want it to do is every time we apply an operation, we decide whether it worked or not, and then based on that we decide whether to bother continuing with the rest of the chain or to break out early, using and then return a nothing. The best description I ever heard of this technique was on Scott Blatcham's website, C#, Fun and Profit, very good website, worth reading, even if you're not interested. So imagine you've got two tracks running parallel to each other. You've got your something track and your nothing track. And every operation you perform is a set of points on the track leading from the something track to the nothing track. Well, everything along the something track involves running a function on the previous answer. The nothing track just says, I'm doing nothing until I post it to the end. So you try each operation to see if it worked. If it didn't work, you switch tracks to the nothing track and you do nothing. And you just coast to the end, applying no further operations. And you just do it with these. So my nothing consists of an override of value, which is default T, which is null if it's an object, null if it's a string, 0 if it's an integer, you know the song, sing with it. And then my maybe contains a value. So then, the magic, as it were, is inside the bind method. So, I've got my two maybe, which is the same as before. It applies to everything, but it just converts whatever it is into a maybe containing. It actually converts it to a just, since it has a value. The other thing is the bind. So that's doing something slightly more complicated now. We have to switch now. Unfortunately, at the moment in C#7, we have to use an operation. This slide will get changed when we use C#8, as of, I think it's in April or May. So, we're doing our magical casting switch based on whatever the current value out of the bind is. That's our new value. So we say, is it a just? That means it has value. When? Now we saw this earlier. This is your generic equality comparer. That's just my generic, is it null, basically. So within this I'm saying, the value that just got spat at me, is it a value? Is it a value? And is that value not null? And if it is not null, if I have that value, then I will take the operation that you just passed me and I'm going to feed that value in and then throw it over the fence. Otherwise, any other case, that is, it's nothing or the value that returned was a null or equivalent, then I can return a new nothing. So that is how you go from something to nothing. you either have a nothing back because you gave a nothing and you get a nothing back, or because you've got a something, you apply your operation and it returns null or equivalent, and it becomes a null. That's my train tracks. That's the whole thing. So think of this as a relay race. It's a relay race with each value, each function operating, taking its return value, passing it to the next one, which executes it, and then you pass on relay race, hand to hand, all the way around to the end. And if at any point someone falls over, fails, or whatever, you just sit the thing out. So all those other operations that would have applied afterwards, you simply don't bother to execute them. So you can define the entire chain once, and you don't need to worry about catching null exceptions. You don't need to worry about what happens if the database returns null or something doesn't work out, because, and you put a try, I think, no, you can see it, but you can put a try catch around that if you just want errors to disappear. So the entire thing becomes extremely robust with an awful lot of functionalities baked in that you don't need to worry about anymore because you keep reusing the same structure. And the name of the overall term for these structures, by the way, is monad. That's what one is. There are far more complicated definitions of monads than this, and some of them make my head hurt, but I am an engineer. I'm not interested in its definition, I'm interested in what it can do for me. That's what it does. It's a robust chain with a bit of logic at the point at which you pass value from one function to the next. That's a monad. So hopefully now you know, tell your friends. Okay. So, a slightly more complicated one. There we go. So I'll just blast through this, we're nearly at the end, folks. Either. So either is a very slightly more complicated version of maybe. The difference is, instead of something and nothing, or whatever, it's got left and right. I don't know why they chose those terms. I find them a bit confusing, but there you go. That's what we call it, left and right. And your left is your unhappy path, that's your failure path. Your right is your happy path. That's it worked. If it all works, you go rights all the way down. If at some point it fails, you shift down to the left. And your left actually has different items on it to the right. So in my case, in fact, I've said that my right has an exception contained in it. So for me, using this, if an error gets thrown at any point in the chain, we shift to a left, and then we have the exception captured. And it will then proliferate all the way down, unchanged, holding that exception. So then at the other end, when you receive your value, you would do something like one of those switches. You'd switch on left or right. If it was right, then you simply return. If it was left, then you do the appropriate error handling procedures, you log, you send emails, you scream for help, whatever you need to do. But now you know, but without actually anything erroring out in any sort of way that you need to worry about it. Gentleman was asking me about error handling, there you go, that's an example. So the either monad, that's another one. And as far as I'm aware, there's a whole load of other monads out there that have all sorts of other operations. I can imagine myself using one that does retries automatically or something like that. When it does, it's fine, but there's all sorts of things you could do. But the left, the either, you could even have the, rather than error, maybe you could have that containing not the proper value that you wanted, but maybe a partial version of it that's enough to do something else, so you can have some graceful degradation in your functionality. There's any number of things you could do with it. It's a very powerful tool that you can do all sorts with. And if I return, this is my last set of slides, and then we can all go home. Okay. Lovely. LanguageX is the only NuGet package I'm aware of that implements a lot of this stuff. It does not do all of the stuff that I've talked about. It certainly has eithers, it's got maybes, it does a lot of the monad stuff. Some of the other functors I've talked about, I didn't see much in the way of those, but you could do an awful lot with it. So if you want something that you haven't had to bake yourself, that's maintained by somebody else, you could certainly have a look at LanguageX. I had a play with it, and you can do an awful lot. Oh, here you go. Sorry, it's not terribly legible, but anyone that's interested can have a look afterwards, but you can do, this is the Fahrenheit Celsius conversions done using LanguageX, so it uses .map. It doesn't bother with the two maybe or anything, it's just map hangs off everything now, and you do match at the end, and match gives two functions based on whether it worked or it didn't work, and then you decide what to do with them. So it's not very different in principle to what I've done, and it's certainly usable. I've had a play with it, it seemed quite nice. I'm just more of a fan of rolling it in personally because I can be more specific. If you want some further reading on this topic, here are a lot of the sources that I use. Functional Programming C# by Enrico Buonanno. This is a Manning book. I thought this book was marvellous. A lot of the techniques were inspired heavily by the stuff in that book. So if you're interested in taking this further, I would certainly recommend the Buonanno book. It's wonderful. I can put this slide back on later if anyone wants to see it. Functional C# by Linebyline. I hope I'm pronouncing that right. That's a packed book. That's pretty good. I liked it. It was a good book. A lot of nice ideas in it. Not as good as the Buonanno one, personally, I thought. The Buonanno one was really quite nice and in-depth. There's a YouTube video that I like from NDC Oslo by Kathleen Dollard called Functional C#. She even covers a lot of ideas that I haven't. Things like, rather than having try catches all over the place, why don't you just have one and then take an action and then apply it? And you just, there's all sorts of things you can do to further break down the amount of actual code you need to write anywhere. That's a good one. A lot of nice ideas in her. There's a couple of Pluralsight talks, one by David Thatcher, another one by Vladimir Kolikov. And also, I've already mentioned the F# Fun and Profit course, Scott Blashin. As I say, even if you're not interested in F# itself, there's a lot of good theory on there that you can apply elsewhere. It's a very good website, and Scott Blashin is a very engaging talk speaker, so if you ever want to hunt down some of his vids on Vimeo or somewhere like that, there's a lot of good stuff out there. And if you really want to go all the way, you can pick up something like Learn Your Haskell for Great Good by Linebyline, which is like the book on Haskell. So there's plenty of places that you could go. Any questions? Stand silence. Oh, the tension is mounting, Matt.
So it's not that good a question. So we were talking before and said that you hadn't done that much with purely functional stuff. So where have you actually taken the inspiration for these patterns from?
So where have I taken inspiration for these patterns, given that I haven't really worked in a pure functional language?
Yes.
It's a good question. From all sorts of places. So I started, to be honest, the journey started probably largely with things like the Kathleen Dollard talk. I was there in person. If you could magically turn the camera around, I could wave at you somehow on that thing if you look on YouTube. I've kind of been aware on the peripheries that functional programming was a thing, and I've been trying for some time before then to try and understand what it was, but once I started to understand the concept, it appealed a lot. And so I started looking at things like the two books I mentioned, the one from Manning. I started looking for any content I could, and I've even read stuff like F# stuff, and I've tinkered with F# a bit, which I liked. But my only criticism, well, not criticism exactly, my only issue with F# as a production language is just that it's quite different to C#. It's sufficiently different that the entire team would have to be very ready to take it on board before you could be prepared to support it. So, but within C#, it's language that most of us all here know, so you can do most of the stuff that you want to do. But in a comfortable environment, you can potentially start putting straight into production today. Okay,
because I'm thinking the bit with the map or bind, where every function is curried, that is very Haskellic. That's very much how everything works in Haskell.
Yeah, I mean, all of these principles, these functional principles, as I said, they date back a long time, over 100 years. So Haskell didn't originate any of this stuff. I mean, Haskell implemented it from what I hear very well. But I mean, a lot of this stuff dates back to stuff like Lisp. And the concept of a functional language, if you ignore the fact that it wasn't in a computer, dates all the way back. Like there were papers in the 1930s that described a lot of this stuff. Like curry goes all the way back. Along the church I showed you at the beginning. He's the guy that came up with that. No, sorry, not curry. But yeah. So none of this stuff is unique to Haskell or whatever. These are just, it's a paradigm, as I said earlier. It's just a way of working. It's a method of composing an application. It's not unique to one language. It's just a pattern to follow. If you go on Wikipedia, you'll find very generic descriptions of all of this stuff. Like without worrying about any individual language, you just implement them.